Now we're going to look at compound and continuous compound interest. In this video we just look at compound interest. In the next one we'll look at continuous compounding. Starting off, should look like a familiar formula. It's our simple interest. But now I'm going to set up a situation here. If t is equal to 1 year, then that would become I equals P times R. So I'm going to talk about the original investment, which is P dollars. So after 1 year, my amount in the bank after 1 year, here's my original principals, and this is my interest. This is what I got from here. But I can factor out a P, and if you'll notice, I come up with this formula. But now, with respect to compound interest, interest earns interest. This money is then reinvested. So here's my new principal, and if I multiply that by R, then I'll get the interest that it earns. But again, notice I've got P times 1 plus R, and on the other term P times 1 plus R. If I factor that out, then it will leave me another 1 plus R, and that would give me, if I shorten it up, P times the quantity squared. But that money's reinvested. Notice that the interest keeps getting reinvested, and that's what compounding means. So if I do this one more time, here's my new principal with the interest included. Multiply that by R to find out how much interest it will earn this year, and I can do the factoring all over again, and I end up with this. So if you'll notice, I've got myself a pattern here, and depending on how many years and how much it's compounded, that will help me get my exponent. So you don't have to worry about this. I just wanted you to see what happens with the interest. Now, here's my next formula, or your next formula. The name of it is compound amount. Now the A is that compound amount or future amount that we've already seen before. P is still principal, R is interest rate, T is time in years. Now the new little variable here is my N, and N is with respect to number of compounding periods, and I'll talk about that more in just a minute. So if you'll notice, N is not only in the denominator here, but also in my exponent. This is multiplication here. Now the R over N determines interest rate per compounding period. The book calls this I. Their formulas are a little bit different, and I really don't want you remembering that this is I, and they also use the N times T. They use another variable for that. That drives me crazy. So I just like the formula as is, and you put the information in where it needs to go. So here's my compounding periods chart. Now you don't put this on your formula sheet. You need to know this. Annual means N equals 1. Semi-annually means N equals 2. Quarterly, N equals 4. Monthly, N equals 12. And daily, we go for N equals 365. So I've got some examples already. Find the interest rate per compounding period. This, like I told you, is what the book calls I for problems 1 and 2. So I've got 6% compounded quarterly. Well, quarterly is 4, so R over N, 0.06, divided by number of compounding periods. So there's my formula. And in this particular problem, that's the information. So if I divide that out, that's what I should end up with. Because, guys, we don't get 6% every compounding period. This is divided through with respect to a year. So you could also say this is 1.5% per quarter. Let's look at this one. Or I could say per compounding period. So R divided by N. I think I'll try and shorten this. So 0.15 divide by 12. 0.15 divide by 12. Or we could say 1.25 per month. 1.25%, excuse me, per month. But now I think they're trying to get you used to finding what they call I, but I really wanted to do these problems so you could see the quarterly and the monthly. I want this formula on your formula sheet. So let's look and see what else I've got. If 2,000 is invested at 7% compounded, I've got three different problems: annually, quarterly, and monthly. What is the amount after 5 years? How much interest is earned? So, what is the amount? That's my A value. I know this is principal. And if you see the word compounded, then you're going to have to use your compounding formulas. So, there's my formula. Remember, I want you to write down your formula and then put in everything where it needs to go. So why don't you try that and see if you come up with what I've got next. So you need to pause me. Annually means 1, and this is 5 years. Please remember your interest rate needs to be changed to decimal. So if you put this in your calculator, parentheses 1 plus 0.07 raised to the 5th. You can put in the whole thing, which is really nice. So that's the amount after 5 years if it's compounded annually. How much interest is earned? Well, remember, if you do A minus P, that will give you your interest. So this is my future amount minus 2,000. Looks like I should have $805.10. Okay, so now all these formulas are going to be the same, because the only thing that's changing is the compounding period. So like I did before, you pause me and put in the appropriate values and see if you come up with that, and put it all in your calculator. Be careful with exponents. If you can multiply this, or if you want the calculator to do it, you're going to have to put this in parentheses. I think I'll do it that way. Let me do second enter because I've got most of the stuff. So I'll need to divide by 4, close parentheses, raised to 4 times 5. I know that's 20, but we will get to situations where the exponents are really nasty. So, you know, if you have to raise something to a product, make sure it's in parentheses. And see if you come up with that. Yay. Interest earned, again. I did go ahead and just write the formula again. And if we subtracted 2,000 from that, looks like we should have $829.56. So why don't you do this one? I'll get rid of the formula. Pause me. I'm going to keep on going, but see if you can do the whole thing. So putting in the information, the only thing that's going to change is my n is going to be 12. So let's see if I did that. I did. And if I put it in my calculator, doing that second enter just saves me a little bit of time. So I'm going to go 1, second insert 12, and then this time it's 12 times 5. So 2,000, there's that. Let's see if I come up with it. Interest earned should be $835.25. So it's just, what, a little less than $6 if we went from quarterly to monthly. The longer it's in there, you know, and the more it's compounded in a year, there is going to be a little bit more money. Now let's look at this next one. How long will it take 5,000 to grow to 7,000 if it's invested at 6% compounded quarterly. How long? How long is time? It's growing to 7,000, so I know this is A and this is P. Notice T is up in the exponent. So I'm going to be pulling something from, why it jumped, pulling something from your history. So put the stuff in where it needs to go. And see if you got that. Now, like we did in simple interest, I don't want to distribute this through. I'm going to divide, and also we can find out what this parentheses is. Let me see what 7,000, which technically is 7 divided by 5. So that's what should be on the left-hand side. And let me see, 0.06 divided by 4. So I should have it in here, and I really don't need my parentheses once I divide by 5,000, 1.015. So let's see if I do. Okay. Now, from your pre-calc or your college algebra, the only way that I have to free an exponent is by doing logarithms. So I'm going to take logarithm of both sides. That's your ln. That's right here. Because I've got what's called the power rule. That 4t comes out front and it multiplies. Okay? So now what I'm going to do next is do this sort of piecemeal. I'm going to get natural log of 1.4. And I'll divide by the first factor. I'm going to divide by 4. And I'll see what I get. Okay? Now, this is a number. Obnoxious, but it is a number. It is multiplying. So I need to divide this thing right here by that. So go and hit your division, and it pulls that answer down. Type in natural log 1.015 and see if you come up with that. So this means it will take, now I'll accept 5.65 years. Okay. Now if you take the 0.65 and multiply that by 12, it tells you how many months. So 5 years, 7 months, and we'll stop there, or 7.8 months. But that's how long it's going to take for that money to grow. So you're going to be running into these, so you need to try and recall that natural log of both sides, which we can then use the power rule, and it brings it out front. And that's it for this one. Thank you.